Hey guys, welcome back to the channel. So in today's video, we're going to be talking about bone structures. So macroscopically and microscopically. And we're going to be talking about, like the structure and obviously how it relates to their functions, how the structures, and bone homeostasis. And we're going to be talking about osteoporosis. So this is one of the most common bone diseases. So first thing first, let me just draw like a big diagram of what I'm going to be talking about today. So we would have, let's just turn this sideways a bit. This is going to be our mind map for today's video. So it's just bone, tissue, composition. All right, so these are going to be the topics we're going to be covering in today's video and in the next one as well. So you've got, cellular components. You've got your extracellular components, so your ECM, and you've got your connective tissues. Right, so here we go. So connective tissues, its function is to support organs and also, stabilize skeletons, the whole skeleton, and basically maintain form of the entire skeleton, right? So connective tissue can be split into two different categories. So first one is going to be your supportive. So we've got support. So I'll just write cartilage just to make it easier, because cartilage is a type of supportive connective tissue. So I'll just write cartilage. And here I'll just write dense fibrous connective tissue, DFCT, dense fibrous. Right. And cartilage can be separated into hyaline, and fibrocartilage. Right. So extracellular, we have two different modes. So we've got inorganic and we've got organic. Right, so the inorganic takes up around 67%. Organic is 33%. And organic is basically, you've got collagen. So this is the main fiber you're gonna see, and just the ground substance, right? It contains H2O. It contains other proteoglycans, So proteoglycans is a type of glycoproteins. Yeah, it's a subclass of it, basically. Cellular, there are 4 types. So let's talk about each of them. It's osteoblast, osteoclast. You've got osteocytes. And also you've got osteogenic cells. Right. So each of them again has function. Osteoblast. Okay. Cartilage, actually, you would have basically the same thing. So what we'll do, so instead of osteo, cartilage would be chondro. Right. So I'll just write it somewhere else later, but that's for another video. So today we're going to be covering just basically this upper half. So this bottom half over here, bottom left half, will be in another video, because this one is a little bit more expansive. We'll just cover the top bit over here, this cellular bit, and the excess extracellular matrix. Right. So, and then the inorganic, you can subdivide them into Ca. Let's see, Ca. I'm pretty sure there is 10 of them. Yep. Ca10, PO4, OH2. Right, so this is a ligand, and we call this the hydroxyapatite. Hydroxyapatite. I'll draw the structure out for you in a moment. And you've got other stuff like calcium carbonate, you know. Like, okay, let me try. It's like a ligand. That's all you need to know. This is a ligand, and the organic stuff is basically responsible for rigidity, right? And plus resist tension, just like that. So yeah, basically if you don't have your inorganic stuff of your ECM, so all your calcium ions and ligand or complex ions, then you know your bones will be really flexible. So you normally the bones will be like this. If you don't have them, you can just bend them. You can just bend them like that, you know. And then so these two basically serve, well, they're grouped together to serve the same function as rigidity. This one for organic stuff, collagen, yes, help resist tension. All right. Then you've also got the ground substance. So depending on how much of H2O there is, it also can resist compression. Right, so this is basically like the function of each part of the ECM. Organic, resist tension, compression. This guy here would also resist compression, I would say, fair bit. Fair bit. Oh, so my bad. The ground substance here is only proteoglycans, and here in organic you would have H2O, because H2O is not an organic compound basically, so it doesn't resist compression. My bad. So basically, let's swap it over. Rigidity and compression for inorganic, and tension for organic. And then we're going to move on to the cells. So osteoblast is responsible for producing the ECM, the matrix, right? So the way I think of it is blast, right? Blasting out. So the osteoblast or the cells would blast out more extracellular matrix stuff, right? So yeah, it produces ECM, that's it. Osteoclast, however, the way I think of it is it destroys your ECM. It destroys your your old bone cells. So it removes excess, remove excess bone matrix, or bone matrix is basically the same thing. Bone matrix, right? So bone matrix, this guy over here, is composed of, you've got so bone matrix, you can find the bone matrix in your medullary cavity. So it's that hollow bit in your bone as you run down. Let me draw a structure for you. So imagine this is your bone. And it's horrible drawing, just bear with me. Imagine this is your bone. You've got all this, so I'll just draw a bunch of dots. Right, imagine just like that. Right, so this part over here is your diaphyses. This part is your epiphyses. This part as well, epiphyses. Right, this is your medullary cavity. And in the medullary cavity, you will find the bone matrix. All right, this is your cancellous bone. This is also your cancellous. But this part over here is your compact bone. Right, so this is basically what a long bone looks like. And basically it's a bone matrix will have a lot of osteoclast. Basically they contain a lot of osteoclast, so they can be broken down. So, and imagine like the structure of bone just like this. Let me draw another one out for you. Be easier to visualize. Let's set this one over here. I'll try and draw. Just hold on with me for a second. I know it looks unbearable. I'm trying to draw like a 3D structure so it's easier for you guys to imagine what I'm talking about. So that, and then you've got this. This is outer structure here. And you've got these, just like that. Just like that. So these structures are quite like interesting to say the least. But basically, it's kind of like this. And you've got a lot of your thingy. These guys will run up. Let me just draw some. So ignore this part over here. I'll just draw it like this. So this is just protruding out, basically. Shit, my bad. So I'm just shading this outer layer. So this here is your cancellous bone, right? This spongy part of here, this is just your blood vessels, plus blood and nerve vessel. Blood and nerve vessels, right? And then you've got, this is your periosteum. That's just the outer layer of the bone, where what happens when your bone is growing appositionally. So your osteoblast would deposit extracellular materials, or extracellular matrix materials outside near the circumference, and then calcium ions will solidify and it will produce this hard outer layer, the periosteum. And here you've got the circumferential lamella, basically your ECM, but with lots of collagen arranged in a specific direction. Right, and let me just draw this out for you. So that would be this one. This entire thing over here is called an osteon. So you've got your circumferential lamella, and you've got these little interstitial lamella. Like, imagine this. This guy would be called interstitial lamella because it's found around the osteons in this central layer over here. All right, so this is an osteon. You've got, so I will try and draw this out over here. Let's try again. You know, I'm always trying my best to draw it out, but I don't think it's gonna work because it's quite hard of a structure. So it goes up and then it kind of curves in, and then you've got this bit over here, 2 layers, just like that. show it to you guys. Just imagine it like this, okay? So you've got these little shaped area. So this is what an osteon from an up above. So your bird's eye view would look like. These little lakes are called lacunae. This entire thing is an osteon. This guy is called lacunae. And lacunae is basically osteocytes. So it's a place where osteocytes are found. Right. This bit in the middle is called the central canal. Right. This is the bit in the middle. And you've got stripes going all the way around like this, and we call these stripes the concentric. So one band of this, right? So this entire band right here, so this entire circular band. So this one, you've got the central canal. You've got 1 band, 2 band, 3 band, 4 band, and each one of this band is called the concentric lamella, right? And these stripes here represent the canaliculi. The canaliculi. So the canaliculi is basically like a channel for minerals and nutrients to travel between your osteon. So through the concentric lamella layers, to provide nutrients for the cells there. Right. So this is what compact bone would look like. Each individual unit called osteons, right? And then over here, I'm trying to draw. So just know that this right here, I'm trying to draw it over here, the structure over here. And it's a bit hard. I'm trying to draw it like opening up this section. It's kind of like this. And then you've got these stripes. It's the same. So stuff like this, for example, this is still your lacunae. And then you've got this endosteum. It is basically the epithelial layer that lines around the central canal, right? And then this is where, so we'll loop back to here first. So osteocytes' function is to monitor and control activity of osteoclast and osteoblast. I'll just write OC and OB like that. And it kind of communicates with the rest of the cell. And osteogenic cells is the stem cells that produce these 3 types of hair and specialize. So the stem cells, when specialized, become one of these 3 types of cell. So osteoblasts can be found around the circumferential lamella, right? Osteoclast can be found in the endosteum, but between the endosteum. So imagine you've got this endosteum here just around the central, that lines the central canal. And then you've got these lamella, right? So concentric lamella. And so it's like that, right? So endosteum. Then it's lying, your osteoclast lie between the cancellous layer and basically this middle part of it here. So it lays around this side here. And osteoclast and osteoblast are both involved in bone homeostasis. I'll go over that in a minute. Yeah. So this is basically the functions of 4 different bones. Osteogenic cells are found in basically the bone marrow or in the medullary cavity here, where when when bone elongation, bone growth like this way happens in the middle of the osteogenic cells will multiply and form longer bones. Right, this is where osteogenic cells are. Osteocytes are found in lacunae. these little legs of your in your osteons, right? And osteoclasts are found between the cancellous bone layer and this middle layer over here. Basically, yeah. And then your osteoblasts are found in the circumferential lamella. Right, so so those are where these 4 types of cells would be found in compact bone, right? So bone matrix again is just ECM, so it's just, I won't subdivide this, same thing. Bone matrix is equal to ECM. Yeah, but then for cancellous or spongy bone, imagine you've got this structure over here. It's quite different. Imagine you've got all of these branches coming out of nowhere, and then you've got these little holes over here. These little holes are the canaliculi, as I said earlier. They allow nutrients and stuff to travel through the trabecular structure. So this entire strut of ECM and bones, basically, this is called a trabecular structure. So between these struts over here, that forms, like, imagine you have a sponge, right? You've got those air gaps or air holes between the spongy material itself, and those air gaps and air holes are called just the air around, so it's the cavity. We call it the cavity, right? And the spongy material itself is called the trabecula, and the cavity contains bone marrow, and bone marrow is the same thing. It's what is found in the medullary cavity in a long bone, right? So it's just extracellular matrix stuff, and then it's made of organic and organic stuff. So that's like the structure. Right. And then this guy can be zoomed in so this is like a structure of its own, and I won't delve deep into that. So we're basically finished with today's video, and also we were talking about homeostasis as well. Yeah, I forgot about that. Let's just do that. So imagine you've got this bone over here. This is your baby bone. This middle layer. As you grow, right, your bones become bigger. So this original same size hole over here now becomes this big. Ooh, okay, and what happens? And this guy also pushes out. So what happens is during growth, right? So this is where osteoclasts destroy the inner layer of the compact bone, basically. Destroys the inner layer. And, basically break down the extracellular matrix into different stuff, like your proteins, your proteoglycans, all your calcium ions and complex ions and stuff, right? Osteoclasts will break down here. So I'll start breaking down here. And then the osteoblasts will take those broken down substances and recycle them by adding them to the outer layer of the bone in the circumferential lamella near the periosteum, right? And it basically makes the grow. So the lumen in this hole, in this bone, becomes bigger, and as well as the overall circumference and diameter of the bone, right, comes bigger like that. So this is when bone growth, right? So bone homeostasis is when the activity of osteoblasts are the same. So homeostasis is when OC activity is equal to OB activity. Right, so this is homeostasis basically, right? And then for diseases where, for example, osteoporosis, where your bone is really brittle and weak, it's because the activity of OC is larger than activity of OB. So the inner part is being broken down more quickly than the outer part is being built, right? And for example, you've got this normal guy, normal bone, and this is your normal. This is your osteoporosis. Right, imagine this bit is thinner. So your compact bone layer is thinner, compact bone, and also weaker bone matrix and weaker, thin, spongy bone, or I'd say cancellous bone. Overall. So the bone is more brittle and weak. Right, and there are different causes. Like, for example, if you don't drink enough milk, or when you don't have enough calcium intake, or when you don't exercise enough, because your body will think that you don't exercise a lot, so you don't need a lot of bone, so it won't deposit so the osteoblast won't deposit as much ECM into the outer layer to build up your bone, so your bones become really weak. So and no exercise, no milk, smoking, drinking alcohol as well. So those are the common factors or the common causes of osteoporosis, right? So your thinner compact bone and thinner cancellous bone as well, because cancellous bone is made of the trabecular structure I showed you earlier, the structure over here, and these structures become thinner, like these struts become thinner, so they're weaker and they're more prone to compression, because these guys are responsible for compression, and if they're weak, compressions happen, bone will fold, bone will break, brittle. So that is like the most common bone disease that will cover, osteoporosis. And in the next video, we'll talk about bone growth, as well as we'll talk about the connective tissue bit, the DFCT, dense fibrous connective tissue, and the cartilage, which is split into hyaline and fibril cartilage. And we'll compare the structures. Thank you for watching today's video, and I'll see you in the next one.